I got to deal with some videos again, but I'm out, so here we go. Next class, we are going to finish 7.3. So today is 7.2 and part of 7.3. Next class, we'll finish 7.3, and then I'll go over any questions you have on the past 2 videos that you've had. Sorry about it. Snow kind of messed us up. So we're going to just start out with 7.2, the Reese's one, and I'm really sorry I can't copy things correctly. So we're going to look at proportions right now. So we're going to calculate mean, standard deviation of the sampling distribution of a sample proportion, determine if a sampling distribution is normal, and calculate probabilities. So what you're going to do first is the first page is review. So I want you to kind of go through that, and then the second page is going to connect the two. So if you don't get that, come back and we'll go through it. So for number 2 on the first page, draw a sample of 50 Reese's Pieces using the applet. I put a link to the applet in the Google Classroom folder. So use that. You should be using, as your number, it should be the 50. So the probability of orange should be 0.4, which is what's up there. The number of candies is 50, and your number of samples is 5. That's number 2. So again, probability 0.4, number of candies 50, number of samples is 5. Add to the dot plot on the board. Once everyone's done, sketch it, so you all have to stay together to do this. Then you're going to do 4, 5, and 6. Again, review of last unit. Use your formulas from your last unit. They're still up on the wall. And then on the back, it's going to go into proportions. So you're going to use the same numbers that you got for before, which everyone has, right? Once you have that dot plot, you're going to turn them all into proportions, and you're going to draw another dot plot. So actually, as a class, you only need to do one. You're going to go through it, mean, standard deviation, see if you can figure it out. I'll talk about it once we get there. And then shape and probability. So pause me right now. Take about 20 minutes, really, with your groups and with the class, and work through the 7.2, page 1 and page 2. Then come back, I'll go through it. Then I'll do big ideas. And then we'll do check, and then we'll move on. So I kind of want to round out 7.2, and then move on. All right, pause me, go. Okay, so we have our large bag of Reese's Pieces. This is binomial. Bins. It's binary, it's orange or not orange. The I, well, it's not independent, because once you take one out, it changes it, but the 10% condition says I can still use binomial. That's important, remember. If it's less than 10% of the population, we can still use binomial because taking one out doesn't make that big of a difference. Think back to the Skittles. Our N is 50 and our P is 0.4. So 2 and 3 depends on your class, obviously. What's important to note here is what each dot represents. So each dot is representing the number of orange from a sample of 50. So each of those dots is the number of oranges in one sample. What we did last unit. If we look at 5 and 6, let's remember our formulas. N times P, so our mean is 20. Notice how I'm using an X here and not an X bar. Standard deviation is a square root of N times P times 1 minus P, so 3.46. Sorry, that got cut off. Approximate shape, it's approximately normal because of large counts. Remember, N times P, N times 1 minus P, those have to be greater than or equal to 10. If they are, we can say, oh, okay, it's approximately normal. Okay, so new stuff on the next page, number 7. You want to use the samples to find the proportion. Now we're looking at proportions, not just the count. So instead of just saying, oh, 20 or 19, it's now 20 out of 50 or 19 out of 50. So whatever it is, P hat, sample, remember, divide by the 50. Now I want you to take a look at the dot plot that you guys made. Notice how I did percentages down here? It should look the same. The shape should be the same. That's the point of this, is it's the same thing. It's just instead of me looking at 19 orange Reese's Pieces, I'm looking at 19 out of 50. So that changes what the dots represent. The dots represent the proportion of orange from a sample of 50. Proportion, keyword. Okay, 10 was tricky. So for 10, the mean of p hat is 20 over 50. Think about it. We got the mean on the front. The mean on the front was 20. So if I turn that into proportion, 20 out of 50 is 0.4. Oh, wait, but that 0.4 was from the original question. That's not a coincidence. The mean of the sampling distribution of a sample proportion is just p. That's always going to work. Because if I do n times p like I did right here, 50 times 0.4, and I divide that by 50, those 50s cancel out. That will always happen. So the mean of the sampling distribution of a proportion is always equal to the true proportion. This one is not as easy to derive just because of it being standard deviation, and with the squaring and the constants, it really would be the variance divided by 50. And I square root that. But these will cancel, right? So actually, this should be a squared right here. Let me change this to a squared. Typo. That's a squared. So that's why you're left with just one n. The reason why it's squared is because this is a variance. Remember, we have to go up. So variance is multiplied by the constant squared or divided by the constant squared. That's why. These formulas, this one, let me highlight, this one, and this one, they're on the formula sheet, so you don't have to memorize them. I just wanted to show you where this came from. Okay, from there, let's take a look at shape. The approximate shape of the sampling distribution is normal. Well, first of all, it was normal before, it's the same shape now, so it's normal. Also, large counts. So, I can do probability. If I know the Reese's Pieces contains exactly 40%, if we select a random sample of 50 candies, what is the probability that the sample proportion will be 50% or greater? Value minus the mean over the standard deviation. Z-score, I subtract because it's greater than, and there's my answer. I want you to remember it as value minus mean over standard deviation because this formula is confusing. That's what we did. We found P as 0.4. We found this up here in number 10. But if you remember it as value minus mean over standard deviation, just find the mean and the standard deviation first. And then it just looks like this rather than looking like this. Up to you. Both ways will work. Okay, let's write this down in our big ideas. So, 3 things. 1, I just want to write those formulas down. It's if the 10% condition is met. The reason for that, we want it to meet the 10% condition, so I can treat it like a binomial. And I want to treat it like a binomial because then I can do that n times p over n and cancel stuff out. So that's if the 10% condition is met, we can do that. It's normal for large counts. And the probability if sampling distribution of p hat is approximately normal is that z-score, value minus mean over standard deviation. So pause me real quick and work on the check your understanding with your group. Should be like 10 minutes. Come back, I'll go over it, and then we'll move on. Okay, mean 0.75. That's just from here. Here and here. Perfect. Standard deviation, that's that formula. P, 0.75, 1 minus P, 0.25 over 1,000 square root. The proportion of young adults who watch online videos in a sample of 1,000, make sure you say what the sample is of, just like in binomial, we had to say how many trials. Typically varies by 0.014 from the true proportion of 0.75. We're talking about proportions now, which is why we're not saying the mean. So true proportion. or mean proportion, whatever you say. Number 3, yes, large counts, we're good. Number 4, again, see how crazy this is, do this instead. The reason why it's 0.73 and 0.77 is because we want it to be within 2. So I took the 0.75, I added 2, I subtracted 2. We want it between those two. Also, this being negative, this being positive, and it being the same number is no coincidence. 0.73 and 0.77 are the same distance from the mean. Therefore, they're going to have the same thing, except it's just going to be negative and positive. Once you get those, table A and subtract your probabilities. Okay, let's move on. So we just did proportions. Now I'm going to do mean standard deviation of the sampling distribution of a sample mean. And then we're going to do probability. So we're going to do the same thing, but with sample means. Okay, you're going to need the height data that is on the desk. Well, might not be on the desks. Algebra 2 trig was just in here. But I also put it in Google Classroom, so you don't have to worry about it. So you are going to take a look at 7.3. I want you to make a guess at the mean. So those are that data, it's made up. So that data is just heights of 50 students. So make a guess at what you think the mean is. Make another guess at what your standard deviation is. Doesn't have to be perfect, but let's remember standard deviation is the average distance from the mean. Using the heights data, so either that sheet on your desk or in Google Classroom, select a random sample of 5 students and calculate the mean height for the sample. You do that 4 times. So you're going to get 4 samples. Make another dot plot on the board. So this one is labeled height, so you should know. Add your sample means to the dot plot on the board, sketch it below. You can just do your group, do 4. This way it's not too crazy. Shape, center, spread, and then compare. So pause me, get going on that. Take like 5 minutes and make sure that all the groups are together. Start adding your dots, and then we can move on from there. Okay, so sampling distribution of X bar, so sample mean. Every class is going to look different, that's why mine's not filled in. However, shape, roughly symmetric. Your center should be about 169. It really just depends on your group. And your variability is going to be much smaller. I'm assuming it's going to be around 3. I could be totally wrong. Oh, I missed number 5 on the last one. I'm sorry. I'll go back to it. I'll go back to number 5 at the end. I don't feel like redoing this. So your shape, symmetric, center, whatever, variability is smaller. Now, up here, actually, I'll just go back to this now. Notice how that's about the same as the population. Same concept with the proportion. Standard deviation, however. Go back to number 5 on check your understanding that I skipped. My bad. If the sample size were 9,000 rather than 1,000, the shape and center are going to stay the same, but variability is going to go down. Remember, as sample size increases, variability decreases. That's from 7.1. It actually is going to decrease by 1/3. Decreases by 1/3. If you want, find the standard deviations back in the check your understanding, and you can divide them, and you'll see that it's about 1/3. Just change the sample size. That leads me into this, which is why I realized I missed it. It's the square root of that 9. It increased by 9 times bigger. So the sample size did. So variability decreases by the square root of 9. So that 1/3, it divides by the 3. So that's what's happening here. It's the standard deviation over the square root of n. So back to number 5. If the sample size were 9,000 rather than 1,000, it went up 9 times. So variability gets divided by 3. If it went up 16 times, variability would be divided by 4. If it went up 25 times, divided by 5. Goes the other way too. If I were to cut the sample size in half, variability will be multiplied by 4, because 2 squared. If I were to divide into thirds, multiplied by 9, because it's just going the other way. So anyway, that's where this comes from. Looking at the two dot plots, shapes and center are similar. Sampling distribution is less variable. The reason for that is we're not looking at individual data points. We're looking at averages of smaller samples. So it should be closer because it's the average of a bunch of them together. And then also just note, if the population is approximately normal, the sampling distribution is approximately normal. Next class, when I'm here, we are going to talk about what happens when it's not normal. So, big ideas. Here we go. Formulas. These, by the way, are also on the formula sheet. Awesome. So, mean of sampling distribution of sample mean is just the population mean. Standard deviation is population standard deviation over square root of n. Normal. If a population is approximately normal, sampling distribution of the sample mean will also be approximately normal. And then z-score. I keep saying value minus mean over standard deviation. The way it's written on your formula sheet, which I'll show you next class, is statistic minus parameter over standard deviation. Take whatever time you have left, maybe not the whole time, maybe come back for like 3 minutes, make sure that you're with me, and work on the check your understanding. The wording is very important, and I made underlines for a reason, so go check that out. Okay, number 1, probability that a randomly chosen pregnant woman has a pregnancy that lasts more than 270 days. My n is just 1. So I'm just doing it normal. 270 minus 266 over 16 is 2.5, so 40.13%. Now it changes. Suppose we choose a simple random sample of 6 pregnant women. Number 1 was only the 1. So let the sample mean be the mean pregnancy length for the sample. Mean of distribution is just 266. It's the same as right here. Boom. There it is. Oh, that was bad. Calculate and interpret the standard deviation. Verify the 10% condition is met. Well, 6 is less than 1/10 of all pregnant women. Done. Standard deviation, 16 over square root of 6, because that's the number of women in my sample. If I take many samples of this size, I expect the sample mean typically varies by 6.532 days from the mean. So, number 4. Find the probability that the mean pregnancy length for the women in the sample exceeds 270 days. I did this on purpose. Same numbers as number 1. The difference. Find the probability that a randomly chosen pregnant woman. Find the probability that the mean pregnancy length for the women. So here I'm looking at a sample before I looked at one individual woman. That's why I need to use this standard deviation. Because here I'm looking at a sample mean, before I was just looking at an individual. So that's how you know when to use the new standard deviation. Okay, that was a lot. Like I said, next class we're going to finish 7.3, and I'm going to go over any questions you may have. Your homework, by the way, if I don't assign you homework, you don't have to do it. I know I said it in the last one just because I used the video from B-Day. This is for A-Day and B-Day. I'm going to give you a couple 7.2 questions just so you can try them and practice them. If there's not in your thing as due, you don't have to do it. I will never give you 43 questions, guys. I usually give you a max of 20, and even that's a rare day. So I appreciate you trying, but if I don't assign it, don't stress about it. There's no due date on it. So finish all this today. Come in with questions next class. We'll finish 7.3. You're going to have a review, and then your test, A-Day's test, is next Wednesday. I will be here in the morning every day. If you owe me a Unit 6 test, that needs to be done either Thursday or Friday morning at 8 a.m. Those are your options. Thursday or Friday morning at 8 a.m. Okay, do the 7.2 in your ebook. Be good for the sub. I will be back. You can come in the morning and ask me questions, and we will address questions in class. So if you have questions, just write them down, and then we'll go over them in class because I bet someone else has the same question. All right, guys. I will see you on Thursday.